Hi, boys and girls. It's me, Butch. My name is Terry David SILVERCLOUD. I'm not native. It just sounds that way. Today, I believe, is the 20th of December. Hope so. I always get it screwed up. It's Saturday, and it is quarter to 3 in the afternoon in Vancouver. And it was a very gloomy morning, but the sun has come out, and I'm testing out my brand new DJI Nano camera. I bitched in another video that I don't like that you need a smartphone in order to activate that camera, which I think pisses me off. Anyhow, I've got it working. I didn't own a smartphone, so getting it working was really a bitch. So this is my very second video I've made using you guys over there. I have to be careful what I do with my hands because I have tracking gimbals, and sometimes they think I'm signaling them to do something. So without further ado, um, I like to get to the bottom of things. So the first thing I'm going to do is get ready to talk to you about helium. Hang on. Now the thing is with helium, Butchie Poo has his own ideas about atomic structure. And he wrote a book called The Shape of God, and he talked about this kind of thing. So I'm 81 years old, and I have a bad ticker. So to because I don't know how long I'm actually going to be alive, I and I don't have a lot of things to talk about anyway, because I'm really just a photographer and a painter. I'm more of a creative type. I try to be creative. I try to entertain, but I'm trying to educate. And my passion and my hobby is quantum physics and particle physics. And so I'm trying to push some of my theories along those lines. And you get to see me being me in front of a camera. So see if I can keep the microphone there and you'll hear me. Um, so Butch likes to get to the bottom of things, and I'm sure you do too. So he's trying to get to the bottom of what exactly is helium. And you would think we would know, but we don't. Well, we know a lot about it. We know a lot about a lot of things. But there's just a poop load of stuff about which we know nothing. And helium is one of those real mysteries in chemistry and physics and everything. We know there's a couple of variations of them. So because I don't want this video to go on like forever, and it's mostly a test of this new camera of mine over here, uh, which wants to tell you his ideas about helium. So quickie off the start, this thing in my paws here, my hand, is what Butchie, ignore the red tape. It's a very old model and it was falling apart, and that's the only tape I had to put it back together. I know it's just a bunch of aluminum tubes, but Butchie Poo says that this is what, if helium got cold enough, and it does, and you want to turn it into a solid, you'll find helium just doesn't do that. So we don't do that here. So you cannot actually freeze helium. You can get awfully close. And Butchie Poo says that, oops, up here, dear, up here, that a girl. Butchie Poo says that if helium could condense from a gas, which is its favorite, over here, dear, there you go. See, that all confused the tracking cameras. Uh, it doesn't know who to watch. Watch me, guys, girls, my tracking cameras, the ones over there. I'm going to touch the screen to make sure it doesn't go black on me. I think I'm recording because the main thing is to test you guy over there. What was I talking about? Right. So that's my model of what helium would look like at the exact point of condensation from a gas to a liquid. Now, the reason I say that is we don't actually know why gases are gases, why liquids are liquids, and why solids are solids. You might think we know, but we don't. And if you go, oh, he's full of shit, you're going to go check me out. I know. Please do. And what you're going to find is your general information will tell you that you will find that in solids, the atoms are tightly packed together, and in liquids, they're further apart, and in gases, they're even further apart. That'll be the generalized explanation upon which you are going to come. And that doesn't tell you a whole lot of things, because if you think about the very solid styrofoam, the atoms are not at all close together. There's other chemical reasons why it's a solid, but generally speaking, that rule isn't a very good one. So Butch decided, because he examined this, because he's into physics, that the reason solids are solids and liquids are liquids and gases are gases is that, see if I can grab this thing over here. This one will have to stop that. All my camera's tracking here. Is that with solids, they have point in their atomic structure or their molecular structure. It's not really important which right here. They have pointy things, vertices, and they have flat surfaces. Those may simply be electronic wave fronts. It doesn't matter. And they actually are, but that's another story I'm not talking about today, which has to do with things that go faster than light. What? Yep. Butchie Poo says that tachyons go at 4/3 pi c cubed, and that in your world of relativity, observing everything at the speed of light, tachyons move at 4/3 pi c cubed. But that's another story. See how I squeeze that in there? How long am I going to go on with this video? I don't know. How long am I going to go on with this video? How long am I going to go on with this video? I don't know. He's a goof. He's old. All right, where was I? So he says that in liquids, in Butchie's definition that he gives, this is all from me, Butch himself, that what defines a liquid is it has a spheroidal shape. Now that shape may be full of lumps, as long as there are no real flat surfaces, and as long as there's no real pointy parts. The bumps may indicate that the liquid is starting to become a solid and starting to form those pointy parts, if you get my drift. Like if you see a ball with a whole bunch of bumps on it and the ball keeps shrinking, it may be obvious to those who think about those things that it's probably going to obtain pointy parts. It's just going to obtain pointy parts. And that's the way it's going to be. So that's Butchie-Pooh's definition. And another way you might think about it is that if you had a spheroid, and this Hoberman sphere here is fairly spheroidal, pretty close, and it's pretty close to what Butch says molecules look like structurally. But as it starts losing energy and giving it off and shrinking, the spheroid starts developing these pointy parts, which I'm fairly certain are quite obvious. And Butchie-Poo says those orangey thingies there are the electrons. So the orangey pointy things are the electrons. Got that? You see the electrons there? Getting a good view of the electron? You getting a good view of the electron? Got a good view of the electron? Okay. You got a good view of the electron? Can you see the electron? Okay. All those little orangey things. Where was I going with that? So getting back to helium, the thing in me with helium is that Butchie-Poo, because he says he knows what solids, liquids, and gases are. Oh, gases, we haven't got to gases yet. So what happens with the spheroid is when a liquid is strictly a liquid at the atomic level, it has a choice in reality of spinning left or spinning right. It can go either way, and what is up and down will depend partially on some other motion, which it's allowed to have as well, because it might be going this way or that way at the same time it's spinning, and it actually is. So because it has a choice of spinning right or left, Um, as it gains more and more energy, the poles will start to flatten of the spheroid, and the equator will get bigger, and eventually it'll develop a hole in the center, and the spheroid will turn into. Oops, you're supposed to be up here. You're not supposed to be down there. You're supposed to be up here. You caught that, right? um, so it'll become a torus, a donut, and if there's more of them, they're tori. That's the way you say it. So gases are tori, liquids are spheroids, even if excuse me, they have bumps on them, and solids have flat sides and vertices. What's that got to do with helium? Let's get back to helium. So helium generally has an atomic weight of 4, and what's that telling you is that it has the same weight as uh, 2 hydrogen atoms with 2 neutrons would have. Oh, that's pretty convenient. And that's pretty much what's going on. So let's get back to the hydrogen. Hydrogen is a gas, and you can have, if hydrogen freezes, it's very easy for it to form tetrahedral shapes. And there's no issues with it. It's nothing restricting it. It just gets smaller and smaller, and it'll form the smallest shape that it may, which is most likely to be a tetrahedron. Now, remember, there was one that spun left and there was one that spun right. Oh, yeah. Well, what happens is it's the same as people living in North America and people living in South America. If they put their feet together, and we do, this happens all the time in physics, each one of them will think they're spinning in the correct direction. The ones from down south, they'll think they're spinning the right way, and the ones up north of the equator, oops, I got to touch this. You got to make sure you're working. Oh, good. You're working. You're working. See, I'm testing out you, and the screen goes, I still haven't really got the hang of everything with you. Um, and that's what happens with the hydrogens. The left spinning and the right spinning, they get together and they just put their feet together and they save energy that way. And it's easy for them to do that. Now, when they do that, you have what's called a molecule of hydrogen. And generally speaking, most of the hydrogen will be in molecular form. There'll be a pair of a left spinning and a right spinning hydrogen. Not to say that there's lots of loosey-goosey hydrogen atoms out there. They're not together yet. So we're just going to think about at the moment the ones that are sort of made it up, because I don't want to confuse you too much. And somehow in our universe, inside of suns and stars, with that incredible heat, the hydrogen, which is a torus, at some point breaks. The ring breaks. And this happens both at the molecular and the atomic level. And that allows one hydrogen trying to get back with another hydrogen to form this kind of shape, where the molecules somehow got knotted. And now that they're knotted, they don't want to come apart. And they don't. So helium, it just does not want to freeze. And the reason is, it's like you can wear tighty whities and Butchie Poo's not wearing the tightest yellow ones he has. But you can only squeeze so far. And when it gets cold out there and your boys are shrinking and shrinking and shrinking and you're going, ooh, that hurts. They only shrink so far. And that's as far as they can go. And it's absolutely well known that if you put liquid helium into a container, it will crawl up the walls of the container. And if you see this model, and Butchie tells you it's 2 hydrogen molecules spinning with each other, this one is spinning this way, and it's rotating this way while it's doing it, and this one is spinning this way and it's rotating this way. So there's basically no friction, and they're like their own little motor spinning away. So Butchie Poo, and this, you're not going to find this in science texts. This is Butch science, and I'm trying to push it. So if you're a nerdy type, you think about it. Ask your professor about. Oh, sorry, I forgot about the mic. I'm supposed to be testing the sound, and I get all carried away. So I don't want this video to go on forever, and now it's getting on, and it was mostly to talk about hydrogen helium, and I thought I could pack more in than I did. Um, so what else can I tell you? Really quickly, even if I do go over 15 minutes, I'm trying to keep under 15 minutes. Something that I've been pushing for the last 30 years, and I noticed there's many videos coming out on the internet about it, so I can't say that I was the first person to think about this. I'm sure lots of people did, but I didn't know about it before I figured it out for myself, and I published it in a book about 25 years ago, so I can't say for certain that other people picked up on the idea. And anyhow, I'm glad it's being pushed. We are part of the Milky Way galaxy. That's pretty common knowledge. And the Milky Way has sort of arms spinning around it, and it's moving through space very, very fast along with another group of galaxies. And I'm not going to worry too much about that. That's extra motion that I'm not even going to get into what I'm about to talk about. Now, we are in one of those arms, and that arm, partly because of the way the Milky Way is turning, like it's revolving, and the fact that we're moving closer and closer to the center of the Milky Way, we move in 1 year. In 1 year, we move 7 billion kilometers. In 1 year. In 1 year, we move 7 billion kilometers. Did you get that? 7 billion kilometers in 1 year. You say, well, so what? Well, the nerds will know. If this is the sun, this yellow ball that I'm holding up here, oops, I have to touch my camera over here. Oh, I think it's working. Please be working. I'm going to find out when I try to edit all this. If the yellow ball is the sun, we are only 93 million miles away from the sun. 93 million. That's like a tenth of 1 billion. Remember I mentioned billion a while ago? Oh, that's in miles. Well, even if I'm mixing miles and kilometers, don't get too excited. I'm old school. It's hard for me to keep them straight. The point is, the Earth is almost on top of the sun in space. So if we try to go 7 billion kilometers where the Earth is going sort of in a sideways way as we move through space, that's not going to work. We can't do this. The reason for that is half the year we would have, because the sun is moving forward, half the year we would have be traveling at a different velocity than the other half of the year between summer and winter. You just can't do that because of a thing called relativity. Time would change the way time works, the way machines work. We're not even 100% certain, but the math predicts that it will, and it does. So we just have to go with it. Butchie Poo knows why, to some extent, but I don't have time in this video. So before I shut up, what I want you to know, it's hard to do. I'm going to try and do it while I'm close to that mic. So I'm going to put this mic here. A minute. So if this is the sun going through space, you have to believe me, the only possible way for the sun to go through space is south pole forward, because it has to cover 7 billion kilometers in 1 year. And during that 1 year, what's going to happen is the Earth, it's going to revolve around the sun, but the sun's moving. So I'm going to get back here to make it more obvious. Hope you can see me way back. I can't see much way back there. So the Earth is going to do one complete turn. So in 1 year, as the sun is moving through space, I can't do it. I get confused watching my different screens. As the sun moves through space, Earth is going to, in fact, make one turn around it. But the Earth also is going to travel 7 billion kilometers. So what really happens is the Earth makes one helical wave in a year through space, and it's 7 billion kilometers long. There's never any actual real circle. The Earth never, or an ellipse, or whatever you want. There never is an actual circle. Circles are an illusion of relative motion. In order to go in a circle and you see something actually see the circle be completed at the same time, that thing has to be going at the speed of light squared. And if you remember, there's a formula E equals mc squared. That's Einstein, and he didn't actually quite figure that out, but it was derived from his equation. Some people say, "Oh, guess what?" And they just sort of saw it in there, which he had sort of missed. It doesn't really matter. It's not taking anything away from him because that's not quite what he was on about at the time. So now this video has gotten really, really long, and I'm going to shut up by turning the cameras off one by one. It's basically a test. If you hate me and you want to dislike me, please say why. And I know some people subscribe because they saw some of my other tamer kind of videos, and then they come across these kind of videos. They, holy crap, he's a queer. Yeah, I'm a faggot, all right. And you know, if you're the kind of person that leaves because I say that, well, bye bye. Oh, I just saw something before I leave. When I was talking about, I said helium cannot freeze, but if it could, it would take this form. This thing here is called a gyrobifastigium. It looks like two peptides. It's two regular. It's a triangular prism. All the sides are equal, and they're at right angles to each other. So I don't know what's going on with this screen over here. It's kind of dim looking. Kind of worries me. Why are you dim looking? I have no idea. One of my screens is looking dim, but it is what it is. It is a test. Guess I'm going to find out. So I'm going to wrap this up. I said if helium could freeze, it would take the form of Johnson solid J. Oops, I touched the screen. It would take the form of Johnson solid J26, the gyro by. That way. More, more, more. Make it more. Make it more. More? More what? More what? Okay, I'm going to shut up. I'm going to go around and start pushing your buttons and turning you off one by one. So the first people I got to say goodbye to is you people up here. Bye-bye. And then I'm going to try to push you off there. I'm not pushing you off. I got to go to other things. Bye.